So let's keep going. Now we're going to do 4, 5, and 6 for the final. So consider a binomial distribution of 200 trials with the expected value of 80 and the standard deviation of 6.9. Use the criteria that is unusual to have data values 2.5 standard deviations above the mean or 2 standard deviations below the mean. So the first question to ask, would it be unusual to have more than 120 successes out of 200 trials? Well, what I'm going to do is this. So remember they said my expected value was 80 and my standard deviation was 6.9. So I'm going to do 80 plus 6.9, which is my standard deviation, times 2.5, because that's how many standard deviations they wanted to know above the mean. So I've got 97.25, which is above the mean. Okay. So anything above that, about 97.25 trials is considered of success is considered kind of outside of it. So it's higher than it. So I wouldn't expect it to happen. So the first question to ask, would it be unusual to have more than 120 successes out of 200 trials? And it would be, because remember, anything over 97.25 is above 2.5 standard deviations from the expected value. So I would expect 120 would be way unusual. So I'm going to say yes, because 120 is more than 2.5 standard deviations above this expected value. Well, then the next one is B. Would it be unusual to have fewer than 40 successes? So again, what I'm going to do it for below the expected value or the mean. So I do 80 minus, and I do the exact same thing. 6.9 times 2.5. Oops. And why am I doing it this way? Because the first one asks above the mean and this one asks below the mean. So I get 62.75. And 40 is below 62.75. So yes, 40 is more than 2.5 standard deviations below the expected value. So it would be unusual. All right, but now it says, would it be unusual to have from 70 to 90 successes out of the 200? Well, if I know I've got from 62 to 97 and 70 to 90 is included in that range, no, it wouldn't be, because it is because 70 to 90 observations is within 2.5 standard deviations of the expected value. Because look, so if I'm looking at 62.75 up to 97.25. So 70 is greater than 62 and 90 is less than 97. So no, 70 to 90 is within the 2.5 standard deviations. Okay. All right. The next one, a z-score of -2 indicates a position in the distribution. Okay. Remember, z-score shows you where a value is in the normal distribution. So for a -2, it shows you that it's below the mean by a distance equal to 2 standard deviations. So it's this one. These aren't correct, because what does 2 points mean? That doesn't mean anything. But the -2 tells you that value is 2 standard deviations below the mean. So that's how you know that one. Okay, and then the next one is sketch the area under the curve. Okay, so my z equals 0.53. Okay, I'm going to use SALT. So I go here, normal distribution, and it says put my z-score in. So I want 0.53. Okay, and it gives me what I want. It gives me 0.70194. So it wants 4 decimal places, so I put 0.7019. Okay, and I'm going to keep everything the way it is, because it's a left-tailed. Because why? Why is it left-tailed? So if I go back and look at this, it says to the area to the left. And left is less than for this one. So that's what my answer is. it's 0.7019. Okay. And if you keep looking down here, it shows you on yours how to get it. And it also shows you how to read it on the table. I am lazy. I'm not going to read it on the table. I'm going to use salt. Hope this helps.